Okay, we made it Friday. Go ahead and get out your homework. Homework was worksheet 10.2b. Hopefully you did okay. Just remember you can always email me with any questions. As usual, here are the answers. I need you guys to check your work. Pause the video, check your work, count up how many you got wrong, and then answer question 1 on the Google Forms. Okay, so hopefully you did well. Here's the calendar. Notice on Monday there will be a quiz. On the bottom of the Google form on Monday, I will post a quiz. You will take the quiz, and then on Wednesday, we will grade that quiz. All right, so you listen up carefully. You're going to take a quiz. This is on the honor system, meaning you're going to take the quiz. I'll give you a time limit. I haven't made the quiz up yet, but it'll be 10, 15 minutes. So you're going to take the quiz. No help, no graphing calculators, no online anything, normal stuff. The only difference is I'm not going to be physically there to watch you take the quiz. So best behavior, and just remember you are responsible for your own ethical behavior. So be a good student. So you're going to take the quiz, and then on Wednesday, I'll post the answers, just like what I'm doing now for homework. You will grade your own quiz, and then you will respond on the Google Forms of how many you got wrong, and then I'll assign the grade for that. So it should be a standard quiz. The quiz will be not on what we're learning today, but the quiz will be everything we've learned so far on Chapter 10, which is basically solving and graphing inequalities up to multiple step. And remember, we still have the special cases of all real numbers or no solutions as well too. Okay. If you have any questions on the quiz or anything like that, I will have I probably am not going to check my computer, every 2 minutes on the weekend, but I will certainly check my email on the weekend every couple hours. So if you have any questions or you're concerns about what's going to be on the quiz, I'll tell you exactly what will be on the quiz. Okay. All right, here's your homework for today. It's another worksheet. What do you know? The worksheet will be found at the bottom of the Google Forms. As always, you can print it off. You can have it open. By now, you guys are all pros of this. You know what to do. All right. Compound inequalities. There are only a few times in Algebra 1 solving quadratics. It would be another case where we literally do something new that you've never seen before, and today is one of them. Compound inequalities and absolute value inequalities, we'll get to that later in the chapter. This is some new stuff. So for those of you that have been, I have half your attention, or you got another window open up and you're watching some YouTube video or whatever, or you're watching Netflix while you're doing this, I really need you to pay attention today and try not to multitask and pay specific attention. So this should not, well, we're not even in the classroom. So usually I show you this and you understand, but hey, you really need to pay attention today. I'm not saying today is tremendously hard. It's not, but it's absolutely new stuff, and you really need to focus. So try to find a nice quiet spot if you can, and let's get this on. All right, we're going to do 4 basic objectives. This should make no sense to you right now. Something about ands and or inequalities. Really weird. Okay. As always, some of the stuff I'm going to teach you, I say it's so easy. I could teach a monkey to do this. You're not monkeys, obviously, but I really do mean that it's pretty simple. And there's some stuff that I'm going to show you today that you got to be a smart monkey.
Danger, Will Robinson. Danger. No, Will Robinson. Danger. Danger, Will Robinson. Danger. No, Will Robinson. Danger.
So for the ones that you got to be a smart monkey, you really need to pay attention. Now, hopefully this actually makes it better. 1, you don't have the distractions of the classroom, and 2, you got the pause and rewind feature, okay? And I guess, okay, so in your notes, I need you to write this down. So here's our first new thing. It's called a compound inequality, And the definition of that is 2 distinct inequalities joined by the word and or. And yes, it does read correctly. It says and or. So that means there's going to be 2 inequalities that are joined literally by the word and or by the word or. Okay, so for those of you writing that down, you still doesn't make any sense. It will when I show you a quick example. Okay, so here's one inequality. Here's another inequality. I'm going to join these literally with the word and or I will join them literally with the word or. And mathematically, this has importance, and that's what we'll explore today. Okay, but the basic concept here is two inequalities joined by two words, either the word and or the word or. All right. So our goal today is to graph both inequalities on one number line. So I'm going to take the inequality there on the left, 2x plus 7 is less than 7, and is a critical word there, and negative 2x plus 1 is greater than 14. Those two inequalities we're going to join together using some special rules for the fact that they are and we will put them both on one number line. Okay. Before we solved one inequality, we graphed on a number line. Now we're going to do it with two, and those two are joined by these special words and, or it could be joined by the word or. We'll get potentially two different potential number lines simply because one has the word and one has the word or. So what I got to do today is I got to teach you these special rules. And the special rules are, what happens if it's an and or what happens if it's an or. Okay? So that's the basic idea. So our new vocabulary, we're going to talk about the words and or. Now, luckily for you, you've been using these words both in regular speech and the mathematical meaning of these words and or already. I'll give you an example. Sometimes your mom says, hey, I need you to brush your teeth and I need you to comb your hair. And the question is, well, what does that mean if I say brush your teeth and comb your hair? Well, let's see. In the real world, that means your mom says you don't have a choice. You got to do both of those things. Okay? In the mathematical sense, an and compound inequality will look something like this. Notice we have two circles there, and it looks like there's a red line in between. Now, we'll get into this. Don't sweat. I just want to give you just an example. This is an example of an and inequality. Okay? Real world example, brush your teeth, comb your hair. Mathematical example. All right, what does an or mean? Well, the easiest way I can explain an or is going to the movies. Okay, so when you go to the movies, you always see something like this. It says PG-13. Well, what does that mean? It says PG-13. You can watch the movie if you're 13, or if you're younger than 13, you have to be accompanied by a parent. Okay, and that is the word or. It doesn't mean you have to be both. It doesn't mean you have to be over 13. It can mean you either are over 13 or you can be accompanied by adult. So that's an example of using the word or. Mathematically, this is what an or looks like. We still have two circles. And notice that our number lines are going in opposite direction. Now, I'm going to caution you, we're looking at some simple cases. There's some other cases that we'll see on day 2 where this is not the case. But in general, at least for today's homework, this is what it's going to look like. The ands are going to be two circles joined between each other, and the ors are going to be two circles going away from each other. Okay. So here's what I got to teach you is how you actually make that graph happen. So the inequalities, once again, it's just going to be two inequalities with the word and in between them. Now, for and inequalities, there's a second form. Okay, the second form will look something like this. Notice they both have the letter M, right? And therefore, there's a way, which I will teach you today, there's a way to combine the two inequalities into one. So it looks like this. It says M is greater than 10 but less than 14. All right. So here's the good news. The good news is that this process is pretty easy, and the other good news is that for ORs, there is no other option. ORs will always be combined with the word OR. Now, if this is starting not to make too much sense to you, it's okay. It's probably, for some of you, this is, you're going to need to see some examples before this really sinks in, okay? But if you want to play the video again, by all means do that. For those of you who just want to head forward and let's see some examples, then yeah, let's do that. Okay, so I need you to write that down in the notes, okay? For an and inequality, I said that's the ones that has two circles and you're shading in between. And I need you to write this down. For and compound inequalities, we're going to combine, that should say graphs, not graphs. We're going to combine the graphs and we're only going to use the overlap. Now, I need you to write down the rule. It probably doesn't make sense now, but it will. Okay? And for OR inequalities, it just basically says you combine both graphs. Okay? ORs will look like this, at least for today, ORs will look like this. Okay? All right, so right now what we're going to do is I'm going to show you some steps, and these are the steps for graphing compound inequalities. Remember, the idea of graphing compound inequalities, you solve the inequalities first and then you graph them. So these were the rules for and or, and this will come into play once we actually do one. So let's do one. All right, so here's a compound inequality. Two inequalities joined with the word or, and it says separate them into two inequalities if necessary. Well, notice I already have two inequalities. For and is the only one that you're going to have to separate into two inequalities, and we'll do that here in a little bit. For ors, there will always be two inequalities. So for ors, then you won't ever have to do the step. For ands, occasionally you will have to separate, because remember, there's one and, but here's another version of the same equation, right? So on this particular one, the one in yellow, you would have to separate into two inequalities. So how about we just talk about that real quick? All right, how do you separate inequalities into two inequalities? So here's another example, breaking up and inequalities, so breaking them up. All right, notice there are actually two inequalities hidden right there. If you cover up the greater than or equal to sign and the 7, if you just cover that up with your thumb, right, you'd be left with, well, you'd be left with that. And if you cover up the 20 and the greater than symbol, right, then you'll be left with that. So what this really does is combine those two inequalities. Ands, right, take those two inequalities and combine them into one. So the second line there is actually the same as the first. So most of the time, mathematicians will write it as the first because it's just a bit more convenient. There's less to write, and I don't have to write the word and. Okay, so how do you break up inequalities? Well, I don't know if you want to call this the thumb method, but you cover up the right side. That would be the less than or equal to sign and the 0. Okay, so it would be that inequality. And the other inequality, cover up the negative 16 and the less than symbol, and it would be that inequality. Okay. I also want you to notice that that's a combination of less than and less than or equal to. So for compound inequalities, both of the inequalities may or may not be exactly the same. One might be greater than, one might be greater than or equal to. Okay. All right, kind of catching on. All right, if you need to see this again, how to break up and inequalities, remember use the thumb method. Rewind the video and watch that. For everyone else, all right, we're just going to go ahead and have you do one because this one isn't too bad. So go ahead and break both of these inequalities. These are two separate problems here. Break up both of these into two separate ones. So the one on the left, break it up into two parts, and the one on the right, break it up into two parts. And then answer, let's see, I think we're on question number 2 on the Google Forms. Okay, how'd you do? So the first one, once again, we cover up the greater than or equal to and the negative 9. You're left with that inequality. Put the word and. Then cover up the negative 3 and the greater than symbol, and you're left with that inequality. So there's your answer to your first one. For the second one, thumb method, cover up the less than or equal to 20. You're left with that. Cover up the negative 1 less than x, and you're left with that. So there are your two inequalities for each one of those compound inequalities. Does that make sense? I don't spend too much time on this because typically students get this immediately. It's not that big of a deal. The bigger question is, well, what do I do with this? And that's what we'll go to next. Okay, so breaking up and inequalities, we're good to go. So let's see how to graph these things. All right, so there's my compound inequality. It's an and. All right, so how do you break this one up? Well, separate it into two. So there's my two inequalities. Does that make sense? Okay. Now, how do you graph these? So step number 2 says solve each inequality. Well, luckily for us, both of those have been solved. Now, eventually we'll get to where these have not been solved, and you'll see the example here in a couple slides. I think like 3 slides from now. Okay, so there's nothing to solve there because it says 1 is less than x and it says x is less than or equal to 3. So both of those inequalities have been solved. The next step is to graph one on top of the other. Here's what I mean by that. Look at the one on the left, right? That x is greater than 1 or 1 is less than x. So we're going to graph that one. So there's the graph of x is greater than 1 or 1 is less than x. Does that make sense? So it's an open circle and it's shade right. The second one, right, underneath of it, I'm going to use the same numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the second one. So it says x is less than or equal to 3. And since this is an and inequality, remember the and is the only one that's written as a compound inequality where it has two of those inequalities without the word, ors will always have the word or on it. That's the easiest way, I guess, to explain it. All right. So you know, the last step is we combine the two. And when we combine the two is what we do is we squeeze the top and the bottom graph together and we only see what overlaps. In other words, you see the red squiggly lines on both of them? If I were to squeeze the top graph onto the bottom graph, there would be a portion that would overlap. And that portion will be between 1 and 3. Notice if I squeeze the top graph onto the bottom graph, the overlap portion, the overlap would be between 1 and 3. And so here's what you do. It says combine the two. So the top one had an open circle on 1, so we need an open circle on 1. The bottom one had a closed circle on 3, so we put a closed circle on 3. And the overlap would be between 1 and 3. Okay? So I always like this method when I initially show students. Most students quickly realize that they can probably, in their heads, figure out what the overlap is. So just be careful with that. If that makes sense to you, go for it. If it doesn't, then graph both of them separately. Now, this will certainly take some more time than normal. Okay, remember our previous method of graphing inequalities, we drew one number. Now we have to, I don't know, we have to figure out a number line, okay, what numbers we need. So what I do is to figure out what numbers I need is I will separate the two inequalities and I'll look at the two numbers and figure out which numbers I need. Did I need to actually go up to 9? No, and I'll just tell you I was lazy. I went up to 9 simply because most of my examples, the answers are somewhere between 1 and 9. All right, so let's do another one. Let's do this one together. If you guys kind of got the hang of that one, go ahead and pause the video, get to the answer, and then check your work. If not, let's do this one together. All right, so step number 1, it's an and. How do I know it's an and? Because it doesn't say the word or. So I need to break this into two inequalities. So the two inequalities is there. Make sense? All right. Now, step number 2 says to solve both of those inequalities. Well, luckily for us, it's been solved. Like I said, we'll get to one that truly needs to be solved after we do one more example. Okay, so I need to graph both of them. So it says x is bigger than 2 and x is less than or equal to 7. So you'll see why I'm using 1 through 9. So my first one, x is bigger than 2. Notice I'm reading that one from right to left. We always read from variable to number. The second one, x is less than or equal to 7. So I got an open circle and a closed circle. Our final answer is those two graphs combined with only the overlap and using both circles. So I need an open circle on 2, I need a closed circle on 7, and the overlap. If we were to combine the top graph and the bottom graph, the only part that would overlap would be between 2 and 7. Does that make sense? All right, now what does it mean mathematically? I mean, we just did a whole bunch of stuff. What does it mean mathematically? It means for both of our compound or for our compound inequalities for both inequalities, what's in red represents the solutions. It means the solutions are anywhere between 2 and 7. Now I'm sure Ben is twitching in his seat right now because he's saying, well, this seems kind of dumb because I could have figured that out right from the very start, right? I mean, it literally says 2 is smaller than x, or x is bigger than 2, but it's smaller than 7. So couldn't I have done that right from the very start? Well, the answer is sure for this one, but as soon as we get to one where you have to solve, that's not true. Okay, so you'll see why that doesn't make sense here in just a second. But what I need you to do right now is I need you to do the next one and to answer. Now you're going to have to play the video or do the problem, pause, do the problem yourself, and then play the video because it says, what was your answer type thing. So go ahead and pause the video, solve this one, and then play the video and check your answer. Okay, so we break this up into two inequalities. I know some of you are saying, well, this seems silly. I already know what it's going to look like from the very start. Yeah, but that's not going to be true when we have to actually solve some things. All right, so the first one, let's see, x is bigger than -5, so there's -5, it's bigger. And the second one, x is smaller than 7, so smaller than 7. And notice it had open circle, closed circle. We combine those two graphs, so open circle on -5, closed circle on 7, shade in between, and that shaded region represents all the answers to this, to include +7, but to exclude -5, but every number in between. Okay? All right, cool. All right. Yeah, so let's do one where you can't tell the answer right from the very start. Okay? All right, one that looks like this. Notice there's some stuff there that we have to do, right? Uh, However, the process, and the stuff I mean is that M isn't by itself. So the process is still the same. We separate it into two inequalities. So there's my first inequality. There's my second inequality, combined with the word and now we have an actual a step where we have to solve each equation. So I'm not saying this is that complicated, but look at each inequation, or look at as an inequality. Look at each inequality. Notice, remember we're in an inequality world, so if we ever multiply or divide by a negative number, we got to flip the inequality. So be careful. So it looks like the one on the left, we add 4 to both sides. Okay, be careful with those negative numbers. And the second one, got to add 4 to both sides. And there's my second one. So there's my two inequalities. M is bigger than or equal to 1, but it's smaller than 3. And that's what you have to graph, right? So we're going to follow the and rules. All right, I needed a separate sheet of paper to do this. There's my two inequalities, right? So M is greater than or equal to 1, but it's smaller than 3. So my combined would be closed circle on 1, open circle on 3, shade between. And that is what represents the answer. Okay, makes sense? These can get a little bit complicated and a little bit ugly, like this one. Oh my word, look at that. All right, don't panic. All right, we're still going to separate it into two inequalities. Right? And I put that one in blue just to illustrate that, hey, some of them you can't tell the answer right from the very start. All right, so let's see. We separated them into two inequalities, and then we solve each one. Now be careful, remember, if you ever multiply or divide by a negative number, you have to flip the inequality. So the one on the left, let's see, that's one of those special case ones where it makes sense not to add 6 to both sides first, but to multiply by 2. So if we multiply both sides by 2, the 2's would cancel, and you would be left with that, which we could solve, right? Add 6, divide by 2. The second one, the same thing. Multiply both sides by 2. 2's would cancel. Add 6 to both sides. Divide by 2. Okay, pause the video, rewind if you need to hear that. But those two in yellow are what we're going to graph. X is bigger than 4, but smaller than 9. Notice on both of these, we're going to have open circles. Open circles. So most of you at this point probably don't need to do this on separate graphs. You can simply go to the final answer because it says X is bigger than 4, but it's smaller than 9. So what's in shaded area right there represents all the solutions to that initial inequality. Is it starting to make sense? I told you today was going to be a little bit weird. All right, let's do one together. All right, so write this down, pause the video, get started. If you need hints, then play the video and check your work as we move along. All right, so this is an and, so we separate it into two inequalities. We solve each one separately. We remember that, we always keep in the back of the mind that we might have to multiply or divide by a negative number. If that's the case, then you got to flip the inequality. This one's not too bad. Just subtract 2 from both sides. So there's my inequality. It says y is bigger than or equal to 3, but smaller than or equal to 9. And for many of you, you can graph this now without doing two inequalities because you know it's between 3 and 9. Between 3 and 9. That makes sense? Okay. If you need more practice on this, I would rewind the video and watch all of the examples for the ones you have to solve again. If not, go ahead and pause the video, get to the answer the question in Google Forms for box 6, and then play the video and check your answer. How'd you do? All right, kind of getting the hang of it? All right, let's see. We break this up into two inequalities. We solve each one separately. So let's see. Add 3 to both sides, and then divide by 2. I'm not dividing by a negative number, so nothing changes. The second one, add 3 to both sides, 12, divided by 2, that would give me a 6. And let's see, so it says x is bigger than or equal to -1, but smaller than or equal to, my animation's out of order there, smaller than or equal to 6. So bigger than -1, smaller than 6, closed circle on both of those. How'd you do? Okay, For some of you, probably need to watch the video again just to get a more general sense of what's going on. For others of you, you're ready to do some of these yourself. That's cool. If you want to just do all the ands first on your homework, that'd be cool. And then we could do the ors. You could rewatch the video for the ors. That'd be fine as well. Well, actually, the Google Forms would mess up, wouldn't it? Yeah, we need to finish this. All right, so I'll talk about the ors. Ors are cool because it's always going to have the word or. So there's no step one, there's no breaking it up into two inequalities because they will always give you two inequalities. All right, but the rules, however, are different. Right? We still need to solve, and this one, both of them are solved. Okay, so here's the difference for or. So we graph each one. So it says x is bigger than or equal to 6, and x is smaller than 4. And the or rule is we're not going to graph the overlap. Hey, check it out. This one has no overlap. The or is, hey, whatever you see there is what you get, meaning we're going to combine the two. We're not going to look for the overlap. We're simply going to squeeze the two together, and we're going to combine. So it's basically the first one and the second one. So in other words, do you need to graph one on top of the other? No, you just graph each one on one number line. Okay, I'm going to show you the two simply because I think visually it makes more sense when I'm teaching it. However, when you're actually doing it, you just do them both on one number line and you're done. Okay, makes sense? All right, let's do another one. All right, so let's see. Ors will already be broken up into both two inequalities, so nothing to do there in step one. Step two is solve. This one's already solved. Okay, so step three is you graph one on top of the other. N is bigger than 2, or it's smaller than -1. We take those two graphs and we squeeze them together and simply write what's left. Right? In other words, we write exactly what appears there. So that's telling me that all the solutions are smaller than -1 or bigger than 2. And now remember, ors, the PG-13, you don't have to be both. For instance, red there is 3. Clearly, for the second inequality, 3 is not smaller than -1, right? But 3 is bigger than 2 for the first one. So this is your PG-13. You're either the graph to the left of -1, or you're the graph to the right of +2. And it satisfies at least one of those. Or you're either 13 or you got your dad or your mom with you, that sort of thing. Okay? All right, so ors are pretty simple. We're just going to jump right into an example. Ooh, we got to do some solving here, don't we? All right, so notice these are definitely different than the previous one. All right, we got two inequalities that we got to solve. So the first one, not bad, right? There's my second one. I'm not sure why I wrote that twice. That seemed kind of extra work there. Let's see, though. On the first one, the one on the left, subtract 5 from both sides. That would give me -1. The second one, we're going to divide by 7. Now be careful. Did we just divide by a negative number? Well, the answer was negative, but we did not divide by a -7. We divided by a +7, so I don't need to flip the inequality. Tonight for homework, there'll be a few that you got to flip the inequality. So those are the two that I need to graph onto 1. So let's see, n is bigger than -1. But it's smaller than -5. I know that graph is incredibly small and hard to see, but you kind of get the idea. The bottom one is the answer. The bottom one is the answer. Okay, makes sense? Okay. Okay. Just remember, pause the video, get to an answer the Google Forms. How'd you do? All right, let's see. The first one, the one on the left, we got to subtract 2. That gives me 9. Divided by 3, that gives me a 3. Second one, subtract 5, that's -32. Oh, then we're dividing by a -4, so we got to flip the inequality because we're dividing by a negative. So that would give me a +8 with a flipped inequality. So let's see, x is smaller than 3 but bigger than 8. So x is smaller than 3, open circle, but x is bigger than 8 with a closed circle. Make sense? How many of you guys got that one right? All right, good job. Hey, as always, you can rewind this, play it as many times as you want. So we did ands and we did ors. Remember, ands, it's only the overlap, and ors, it's the whole darn thing, everything together. Okay, and yeah, if you need any help, make sure we got 2 days to get this one done. So make sure you email me at least. I will check it every couple hours on Friday and Saturday. So on a normal thing for Monday through Friday, I'll have it constantly on. The computer will be next to me from 7 o'clock until 3:30. But for Friday and Saturday, yeah, I'm gonna take a little bit of break occasionally, but I will be able to answer your email for questions. All right. So with that, we'll conclude the class. You guys have a great weekend, and I will see you guys on Monday. email me for any specific questions.